Welcome to Qamar MoonBoy channel, and be ready to watch this video and these many kind of video I prepare on my channel. So be ready to subscribe my channel by clicking on the subscribe button on the left now or in the below of this video. If you have already subscribed to my channel and you are not getting any notifications about my new video, so anytime I place a video you get notifications by clicking on this bell icon on the right. So click on this bell icon and check this box and save it so that you can get all the notifications whatever video I am placing on my channel. For next time, if you want a particular video on my channel to watch, so you can go to the playlist here for a particular type of video you want to watch, because every time I add a video I add to that type of playlist always. So you can go to that playlist and you can subscribe or save that playlist to your list. So being all that said, just now start our today's video. Hello, hi, welcome to Qamar MoonBoy channel, and today we are going to learn about the Etabs 2015, another tutorial that is about making a truss in Etabs 2015. So how to create a truss structure, and how to analyze it, and how to design a truss structure inside Etabs 2015. We will be looking about that. So be ready to comment below your questions, and just subscribe my channel and share this video with your friends and all the civil engineers in the world. So let's start it. So in this I'll be starting with the new model. So let us use the Indian standard codes, SI system, Indian codes, steel sections. Steel design section is nothing but IS 800 2007, and concrete design code we don't require that, still we are saving it as Indian codes. So press OK. Now for truss we should consider two-story building with typical height is your height of the truss, that is 1.5 meter I am taking, and the bottom story height is nothing but the height of the pillar, or that is I am taking as 6-meter height, that is height of the pillar. That is mostly we use truss for the uh, factory or workshops. So in that uh, labs or workshops we use mostly the high, okay, height of the building, so the structure will be very at the high state. So we will take three three grid lines in x direction, and we'll take in y direction mostly six spans. So I will be taking as a that is six spans, that is 7 grid lines. So in x directions the grid lines spacing will be it will be it will be 7 meters, and in y direction we will be taking it as 4 meters center to center. Okay, the trusses will be at 4 meters center to center. So and the total span of the truss will be, that is the principal rafter will be of 7 plus 7, that is 14 meters. So we will be taking at a grid only, and press on OK. So first of all we should know about the trusses. What truss should we design for this building, uh, for this structure? What truss should we take? So the trusses are of different types. There is king post truss, queen post truss, HOWE truss or flat truss. Okay, different types of trusses are there. I'll be showing you just a picture of truss. So here are the few types of trusses you can see. That is, the first is this is king post truss, and English HOWE truss, Pratt truss, and a Fink truss. Okay, so these are the side truss alignments. So I'll be selecting the auto select option for the truss members, and it will be selected automatically by the program, and after design we will be selecting this as auto. Then that will be after designing, again we have to analyze one more time so that we can get the correct sizes and economical sections of the truss members. So next, what type of truss I should design. You can see that king post truss and English HOWE truss are mostly used in the areas of workshops and lab mechanical labs. So I will be doing this one, this HOWE truss I will be doing now. So let us do this truss now. This, okay. Let it be, keep it aside so that I can look at it every time and I can make it okay. So first we have to go into the elevation view, or not this one, yeah, one. So in this view I'll be taking the truss. So there are a few guidelines for selecting the height of the truss and everything. So I have taken height of the truss as 1.5 meters. We can increase that also. It doesn't matter actually if our truss is based on the length of the structure. So let us define the sections. Frame section. For this, import properties, steel eye flange, so all properties of eye sections have been made available here. Now I will be creating a new property with the auto select list, and I will be selecting all of these and I will be adding to this. So let us name it as truss member. So it can be used as a beam or column or rafter or strut or anything in the truss now, because it is auto selected list. So this is auto member, so truss member I am selecting. So in this I am keeping all the steel tables members in this auto select list. So the program will select which is economical, and that we can replace it if we don't want that to be in that place, so we can change it at any time. So for tutorial purpose it is uh, auto select list I have selected, so let us go with it. Press OK now, and you can see that truss member is available here. Then you can press OK. So now go for the beam design, that is principal rafter and the purlins. So first we will go for the principal rafter and the angle brace members. Then we will put the central strut and the brace. After that the bracings. So first we need to give the uh, this principal rafter, this one, this member. Then after that strut and this, okay, the loading actual the rafter. Okay, so go to the draw beam menu here. Select your frame here. Oh, okay. We will be selecting truss member here. Okay, the principal rafter I have drawn. Then the rafter. Okay, so press it again so that we can start fresh. Then the strut at the center, that is post. Okay, these three members are over. Now we will be putting the columns. You can come in the plan view. Auto lateral column, or you can take truss member, same. So two columns I have mentioned. Now go to the ground floor and select the column points. Make these joints as fixed joints. Assign joints, restraints, fixed, apply. Okay. Refresh the view. Then you can see that the joints are fixed now. So let us uh, design the frame again. Mostly now we can see our base structure. This should be divided into three members, 1, 2 and 3 member. So it should be divided into three members, and this side this should be divided into three members equally. So we can do that by selecting these two members. So I've selected these. Go to edit frames, divide frames. So divide into three frames, apply. Okay, now you can see these are divided into three members. So now you can select again the beam, draw beam option. Now first joint, parallel to Z. Again, drawing control, you take parallel to Z. Similarly on this side, joint one. Again, one more. Now we are going to draw these brace members. This will be joining the principal rafter at the bottom at the center of the post. So these are sloped at different angles. So we will just select the beam member and we will take it like this. Another way, once more click on the beam member and just place it like that. One more like this way, and click on that again, and our truss is ready. This is HOWE truss, English truss. So this is how you can make a truss member in Etabs 2015. So next we are going to select this span of a truss member, and we will be dividing in this horizontal level. We will be taking as a six base of this truss distance at 4 meters center to center. So select the trusses by the select object tool and select the whole truss and do replicate in the dy direction for 4 meters what we have taken, or you can pick 2 points from here, and the number of times is nothing but 6. One is already present. Let us see the apply button. Yep, you can see that our truss is properly placed at 4 meters center to center at every grid. So press OK. Now our truss is ready. Now on that we have to place the sheet roof, that is truss sheet roof, and we have to place the purlins joining the below the sheet roof. So let us go for the purlins now. The purlins will be at 0.5 meters or 0.7 meters center to center. So the purlins are nothing but uh, the supports for the sheet, which are below the sheet and on the rafter. So we should divide this rafter into let us see the length of this rafter, how much length is there. You can see that the length of the full rafter is nothing but 7.15 meters. So these are full one rafter is there. So we will be dividing this rafter into, that is, 10 segments. Then it will be of 0.7 meter each. Okay, so go to edit frames and divide frames, then number of divisions is nothing but 10, and apply. Okay, now if you select the one segment of it, you will see that one one minute. Yeah, so it is 0.7 meters, 0.715, that is 0.716 meters. So it's nearly of 700 mm I am taking. So I have divided this reftar into 10. Okay, so now I'll be connecting these truss with the purlins. Purlins can be C purlins or Z purlins or pipes you can provide. So let us go to define and define the purlins. Go to the frame section, add new property. We will be taking as the box tube or the round pipe purlins. So mostly we provide available with us these two types of purlins in India. So I'll be selecting it as steel tube, this tube like structure, and this will be of 50 mm by 50 mm, flange thickness 3 mm, web thickness 3 mm. So 3 mm thickness, these will be the pipes, and obviously you have not mentioned the materials here. We'll be taking as first one. So rename this one with purlins. So I am using as purlin tube. Corner radius is 2 mm. Yep, 2 mm corner radius. Press OK. Purlins are ready. Press OK again. Now we are ready to draw the purlins. So go to this 3D view to draw the purlins, and select on draw beam option. Select the member as purlins here, and now you can draw purlins one by one. Uh-oh. On the perpendicular projection, oh no, we have to divide this also into 10 segments. So let us select this, go to the 2 yeah, and select these members and divide them also into 10 frames. Now go to the select draw beam purlins property is selected here. Then from joint, this joint to this time the joint will be available in this. Yeah, again from this joint, again from this joint, not this one because this is not in this zero point 0.7 meters. Again this joint, next one, this joint, this one. Like this you go on doing this until you reach the top of the truss. You can mirror this on the other side, or you can draw again on the other side too. So let us try to mirror these purlins. Go to select all the purlins. Deselect this one because this will not be needed on that side. Go to replicate, mirror, pick 2 points. Yep. So you have to select these two center points to mirror from this side to that side. Then press on apply. Okay. And you can see that the number of purlins this side is mirrored on the other side. So it is easy to do like that directly, or in the or use the mirror option. So next we will be selecting all the purlins now, and we will be replicating to all this other base, that is 4 meters into the center. Each truss we will be making it available. So next let us zoom out this one and rotate a bit to select the purlins, or you can go to select option and select properties, frame sections, and do select the purlins here. Press on select, all the purlins will get selected. Then go to the edit menu and press on replicate. This time we'll be doing a linear replicate in 4 meters, and this time we'll do 5 times. And you can see that I'm pressing apply, and this is going up to this last truss. Press on OK, close. And now we are going to put the sheet roof on this truss so that we can apply the loads, or directly we can do go to the section properties, slab sections, this time we will take as membrane slab. So modify the plank one, name it as sheet roof, select a 992 FY50 because we have not selected the Indian member, that is Indian steel grade. We can select that also if you do it the first time. So membrane, use one-way slab load distribution, type is slab, and let it be the thickness of the sheet is 3 mm. Okay, now go to the draw option, draw sheet. This draw floor slab. Select sheet roof here. Then select the corners of the trusses here, center of the truss, center of the other truss on the grid 2, then grid point A2 at story 1 again, and lastly select the point where we have started. The slab is ready. Like this, you can select on this side, select the first point at C1 story 1, at C2 story 1, then at the center of the story 2, that is B2 story 2, and B1 story 2, then on the C1 story 1 again to complete the slab section. Now go out of the draw menu by selecting this arrow, then select this 2 slab and replicate again. Residue is 4 meter, number of time is 5, apply. Okay, now you can see that our slab is ready and our truss is totally ready now. Now we have to apply the loads and we have to design the structure, so we will see it in our next video. So continue watching the part 2 after this one. This is how you create a English HOWE truss using Etabs 2015. In next video we will be analyzing and designing this truss. Okay, thank you for watching. Bye bye, have a nice day.